So today we will study the topic of pons. Pons is present between medulla and between midbrain. Midbrain is above pons and medulla is below pons. So pons is separated from medulla by this line, which is called pontomedullary junction, and it is separated from midbrain by the superior pontine junction. So now come towards differentiation point of the pons from medulla and midbrain. It is differentiated from medulla by its midline swelling, which is made by basilar artery. Now, why it is named as pons? It is named as pons because it works as a bridge between the two cerebellar hemispheres and between midbrain and medulla. It is connecting the two cerebellar hemispheres. Okay, now come to the nuclei of pons. A lot of nuclei are present in pons. We will take a part of pons. So take it as a median line, and take it as the most lateral line or most lateral boundary of the pons. It is the median boundary, it is the most lateral boundary of the pons. So starting from the most medial nuclei towards the most lateral nuclei, we will study these nuclei as such. So most medially there is present a bunch of fibers which is connected all the brainstem and which is present in all the brainstem. It is present in medulla as well as in the midbrain. It is called medial longitudinal fasciculus. That's why I write MLF here. Medial longitudinal fasciculus is connecting your main nuclei present in your brainstem. For example, it is connecting your oculomotor nuclei and your abducent nuclei. So due to this connection between oculomotor nerve and between abducent nerve, conjoint movement of your eyes are possible, mean that while one of your eye is abducting, the other eye of yours is adducted. So this is because of this medial longitudinal fasciculus. Now at the lateral side of medial longitudinal fasciculus, there is present medial trigeminal nuclei or medial trigeminal part of the central trigeminal nuclei. Now at the lateral side of the medial trigeminal nuclei, there is present your sensory trigeminal part of your central trigeminal nuclei. On the lateral side of your sensory trigeminal nuclei, there is present your sixth nerve nuclei, that is your abducent nerve nuclei. Now at the lateral side of your sixth nerve nuclei, there is present a parasympathetic nucleus which is called why I made I here? It is denoting something. Yes, it is denoting your lacrimatory nucleus or your salivatory nucleus. Both of names are given to this one nuclei. It is a parasympathetic nuclei. At the lateral side of this parasympathetic nuclei, here is present your nucleus of tractus solitarius, which has medial part and lateral part. On the lateral side of the tractus solitarius, there is present your vestibular nuclei, Vestibular nuclei is actually present on the pontine junction. Half of its part is present above the pontomedullary junction, and one nuclei, only inferior nuclei of the vestibular nuclear complex, is present in medulla. The other three nuclei are contained in your pons section. Okay, so we should focus on these two nuclei now. These two nuclei are your cochlear nuclei. This is your dorsal cochlear nuclei. This is your ventral cochlear nuclei. Fibers from both dorsal cochlear nuclei and ventral cochlear nuclei come here, and they cross with the fibers coming from other two cochlear nuclei, that is your dorsal cochlear nuclei and your ventral cochlear nuclei. They are making decussation here, or you can say they are crossing here. The crossing spot of your cochlear fibers is called trapezoid body. Trapezoid body. And nuclei present at the spot of crossing of these cochlear fibers are cochlear nuclei. These nuclei are trapezoid nuclei. These nuclei at the spot of trapezoid body are called trapezoid nuclei. Now these crossed fibers, when go upward, these fibers which are going upward from the spot of crossing are called lateral lemniscus. So lateral lemniscus are the fibers which are coming from your trapezoid body, further proceeding towards your superior olivary nuclei. Actually, these are concerned with your auditory system, and these fibers are taking auditory information first to the trapezoid body, and then through lateral lemniscus to your superior olivary nuclei, and then further these information go to your midbrain to colliculi, and then through brachium to your cerebral cortex and thalami, etc.